All right, here is a video for how to wrap words around repeated measures and mixed models ANOVA. So first thing you do is you talk about the main effects. So that RM factor 1, in this analysis, this was from the example that I did in class where we are looking at changes in energy levels morning compared to evening. And in this example, the between groups factor, or the between subjects effect, is state. So I had 3 different states. I think it was like California, Boston. I don't know why I picked Boston. That's a city. And Atlanta. So that's not really states. Those are cities. Anyway, just go with me. There's 3 of them. Okay. So first, is it statistically significant? And there's 2 main effects. One is for change over time, which is RM factor 1. And that is when you combine the people from all 3 different states and put them together, is their energy level different in the morning and in the evening? And this is statistically significant. So you have a statistically significant difference between the morning and evening energy levels. And that means the difference in the samples, sample means, is not due to chance, and there's a difference in the population means. Now, again, this is like before when controlling for other effects. So the main effect for time, morning or evening, is statistically significant when controlling for the interaction effect of time and state and the main effect of state or city, whichever one. So that's what we know. There is a significant difference when you combine the states together of morning and evening. The difference in sample means was not due to chance. The population means are different. We don't really know what the means are for the morning and evening energy levels, so we can't say which one has the higher or lower mean. That comes later. So next thing you do is look at the marginal means in the post hoc tests. So let's skip the post hoc test for just a minute. Marginal means, level 1, level 2. Level 2 has the higher mean. We already know it's statistically significant. So we can say that in the population across the 3 different states, when you combine them, energy levels are higher in the evening than in the morning. And that is true when controlling for the main effect of state and the interaction of state and time. The marginal means for state, that is the between subjects effect. That was statistically significant. Forgot to talk about that earlier. So there's a difference between the energy levels across the 2 time points combined for the 3 different locations. We know that the difference in the sample means was not due to chance. We don't know yet which population means differ. So if we look at this here, the marginal means, it looks like people's energy levels are the lowest in Boston, the highest in California, and in between in Atlanta. Now, we don't know if those differences are statistically significant or which ones are significantly different from each other. Until we look at the post hoc comparison, we see Atlanta is higher than Boston. Atlanta is not, or not higher, is, Atlanta is higher than Boston. That's significant. Atlanta is not significantly different from California, and Boston and California are not different from each other. So in the population, Atlanta has a higher mean than Boston, but there's no difference in the population means of Atlanta and California and Boston, which I don't really get why California and Boston are not significantly different. Something strange is going on. Here it looks like that difference is 1.33. Here it's saying the difference is 0.55. Oh, so I'm not sure exactly what's going on there. That's very odd. It's possible that that difference is looking at is when you control for the interaction effect and the other main effect, and that these marginal means are not adjusted for those. Maybe that's what's going on. I'm not familiar enough with JASP to know exactly what's causing that. Okay, finally, you talk about the interaction effects. We know that the interaction was statistically significant. We can see that here. That's statistically significant. So when you control for the main effect of the within subjects factor and the main effect of the between subjects factor, the interaction of state between subjects and time within subjects is statistically significant. Now, if we look at the means for each group by each location, we can see that energy level is higher in the morning than it is in the evening for people in Atlanta, and the opposite effect is true for people in Boston and California, and that's what's causing the interaction. Energy level goes way up from morning to evening in California and in Boston, but it goes down a little bit in Atlanta, and that is where the interaction effect is coming from. So you can take a look at these means, these marginal means, and the graph together. They tell the same thing, and use those to describe what's happening in the interaction. So that is it for wrapping words around the main effects and the interaction effects of repeated measures and mixed model ANOVA.